Light and sound can be reflected, refracted, diffracted and show interference patterns. Those are all things that only waves can do. Sounds exhausting. We'll see exactly what they all are in a minute. But just before that, you need to know two important differences between light and sound. First, it's that old transverse versus longitudinal thing. Light is a transverse wave and sound is longitudinal. Ooh, pretty. Second, sound has to travel through something, a gas, like air or a liquid or a solid. But light waves can travel through a vacuum. Show-offs. Of the many wonderful things waves can do, let's start with reflection. This is probably the most familiar and popular. When light waves hit a really smooth surface like polished glass or metal, the waves are reflected so uniformly that we can see a clear image. Pretty simple, a bit like this guy. Not so simple maybe if the mirror is curved, like this, but it's still reflection, and it's used in things like telescopes. Sound can be reflected too. If a surface is smooth, then it will reflect sound waves clearly and produce a strong echo. Now on to the next wave thing, refraction. Sounds a bit like reflection, but it's totally different. When this light wave enters the water, it changes direction slightly. This is called refraction. It happens when light crosses between materials of different densities, like air, water, glass, or transparent plastic. Beyond a certain angle, the light doesn't cross the boundary. Instead, it gets reflected back. In glass, this critical angle is 42 degrees. It's called total internal reflection, and fibre optics rely on it. Very little light is absorbed by the glass, which forms the fibre optic cable. Light goes in at one end and travels down the fibre, even around bends. Nifty! As long as the cables are not bent any tighter than 42 degrees, then light will be contained inside the fibre. Optic fibres are used in endoscopes, mini cameras doctors use to look inside people. And optic fibres are used in phone and broadband cables too.